Even if the CMB is completely flat, this deviation of the photon's path through gravitational lensing leads to fluctuations as observed by us today. So that's the one effect. The other effect is that the photons propagate and scatter on electrons, which become trapped in these potential wells, and that changes the energy of the photon, and that also then leads to fluctuations which would appear even if the CMB were completely flat at a redshift of 1100. The third effect is that the photons propagate, and as they enter a potential well which is growing through structure formation, the potential has a different depth than when the photon exits, because there's a little bit of time as the photon propagates through, and at that time the potential changes its depth. And so the photons change their energy because of this effect. And all these three thus lead to fluctuations which we have to calculate away out of the data in order, so we have to correct the observed CMB to obtain the true fluctuations at the redshift of 1100. And there's the fourth effect, and the fourth effect is that as the universe evolves and expands and structures form, there are now sources appearing. So galaxies which form, they have starbursts, and they emit light, which is scattered and downgraded in energy by dust. And so there are these four effects: the foreground, the new light sources which appear after the redshift of 1100, and these three other effects which change the energy of the photons and the direction of the photons, which have to be taken into account to calculate from the observed flux the actual one at a redshift of 1100. The problem with this, and this is basically already clear from what I've been saying, that these corrections, these four corrections, are sensitive to the model of structure formation, because we cannot observe how structures form. We need a model to correct these photons propagating to us, and subtract the new photons which arise from structure formation and from star formation, and this is specific for a cosmological model. That means if I now take a completely different cosmological model, which for example does not have dark matter and might not even have dark energy, then the structure formation will be very different. It might be much earlier. There might be much more luminous galaxies starting to shine much earlier. This is in fact what we observe with the JWST. And so the corrections I have to apply to the observed background will be different to the current corrections applied in the lambda CDM model. And so the corrections applied for some other model, call it the Bohemian model or the new HDM model, in that model the CMB at a redshift of 1100 might have a different power spectrum, which we don't know because we have not calculated it, and we cannot calculate it because we don't know how the structures form in these type of different models, and therefore it is actually logically wrong to develop a cosmological model which is very different to the lambda CDM model, and to force it to fit the published Planck power spectrum at a redshift from 1100. This implies a logical inconsistency in the actual model, because that model will have a different power spectrums because structures form differently. We see this very nicely, for example, particularly on the Mie-stellar result, where the potentials around isolated galaxies extend to a megaparsec and they are flat. It's as if the galaxy has a halo of phantom dark matter around it, which rises in mass linearly with distance out to this distance of a megaparsec. And an NFW halo, which comes out of the lambda CDM theory of structure formation, does not have that property. It cuts off much earlier, and so the lensing corrections will be potentially much stronger than what we currently are using to calculate the CMB at the redshift of 1100. So this is just one example of where we already know that there will be an effect. Also, if structures form much more early than currently thought according to the model, lambda CDM model, then of course all these effects of photon deviations from lensing and the new sources of light and the change of the photon energy as it propagates through the early universe will be different through the early compact, dense universe, right? So when the first structures start to form, redshift of say 10, 15, maybe even 20. And so this is just to mean that as a concluding a statement, that it is logically incorrect to use the published power spectrum to force that as an initial condition for a model which is not a lambda CDM model.